morning. We are here with Stephen Oliver from Navitas that will tell us more about the company and why they are coming to PCIM Europe.
Thank you, Antonio. Yes, so here we are, Navitas, PCIM 2023. This is a big step for Navitas. In the past, we focused on mobile fast charging. For example, the Realme phone that has a 240 watt fast charger, which will do 0 to 100% in 9 minutes. From there, we've grown into higher power applications like TV power supply, motor drive for home appliance, and also going into now silicon carbide. So we're going from 20 watts to 20 megawatt applications.
Okay, so there are so this maybe is new to our community that you were involved in the fast charging industry. That maybe you can tell us more about what are the news at your booth here at PCIM.
Right.
What you bring.
What do we bring? So over here on the left-hand side, we have our new range of GaN sense control. Here we're using our integrated high voltage GaN power ICs plus a silicon system controller. So this is a co-pack for maybe up to 65 watt applications. As we go forward, you can see the benefit of going to higher speed, higher frequency, shrinking things down. We go 6 times faster and we get much improved power density. Here you've got the big names, Dell, Xiaomi, Motorola, Belkin, Anker, Lenovo, Samsung, all of these guys who are making really nice applications. And then we look forward and you can see that as we go higher in power, the benefit again increases. This is a traditional silicon-based 240 watt charger. This is the new gallium nitride version. So you can see a huge shrink in size and weight, and also system cost as we move into higher power. As we move across, this is one of our recent products. On the left-hand side, this is a discrete half bridge. So there are other people doing gallium nitride, but they do discrete products, so it's just a switch. So to make a half bridge, you have all of these components, and also you have some ringing and glitching in the application. The Navitas version takes all of these things and shrinks them into a tiny surface mount package. So this now is integrated 2 GaN switches, 2 GaN drive, level shifter, bootstrap protection, a real easy to use digital in, power out IC.
Okay, very good.
We move into the home appliance area. We go from a silicon example to the gallium nitride. TV from silicon to gallium nitride with our power ICs. For a TV, the area is not so important because TVs are large, but the height is critical. So frequency, we can go to these surface mount transformers. These are planar magnetics. The wires for primary and secondary are in the PCB.
So this is what was before and what is now?
That's correct. The old silicon and the new GaN fast power IC based unit.
Is the idea on how you can integrate things better and get better accuracy?
That's correct.
And security and
yes. You go from a toroid transformer to a planar transformer, the manufacturing accuracy improves. On this side, we're looking at, this is a motor drive, a 300 watt with no heatsink, 400 watts with heatsink. These are now 3 of our half-bridge GaN power ICs. So it's a high-frequency system, very, very small. This is very popular, especially for some European customers, shipping millions per quarter.
Oh, wow.
And on the right-hand side, if you go above, say, 500 watts, you should probably split out the devices. So this now is our 1 kilowatt motor drive. So we have separate high side, low side GaN power ICs with lossless current sensing. Our GaN Sense range does lossless current sensing. So this is, going up to 500 watts or kilowatts. Now let's take a look at multi-kilowatt designs.
Okay.
And now we'll start with some higher power applications using GaN. On the left-hand side here, we see an industrial or high voltage DC data center application, really comparing this old silicon 750 watt brick, full brick, to this unit with the gallium nitride power ICs. This is now a quarter brick with even more power. So it shows that going high speed with gallium nitride shrinks things down. It's the same story when we get to a big AC-DC supply. This unit from Navitas, this is actually a reference design from our design team. And as you can see, this is half the size of the silicon version. It is also higher efficiency than the European specification, the new Titanium Plus grade. And this, our customers have told us, is less cost for the system than the old silicon. So we have the efficiency, the size, and the price point. Now this is now a 3-in-1 EV charger for 400 volt battery. In this case, we have 3 functions. Number 1, to go from AC to 400 volts DC. Number 2, in case the power in your home goes out, 400 volts back to AC. And the third one, from 400 volts down to low voltage for your radio and your seat motors. And this is around 3 times smaller than you could do with an old silicon-based system. So this is really the future. Now from 400 volts, if you want an 800 volt system for EV, now we're in the world of silicon carbide. And for silicon carbide, we have the Genesic range of technology. We bought the Genesic company in August 2022. Great addition, excellent engineers, excellent technology. Here we have some demonstration boards that we've been validating the product. On the left-hand side, this is a new entry this week at PCIM. So just released. This is our generation number 5 merged pin Schottky diode range. Now also for the first time in a QFN surface mount package, going to TO247s. We also have the common cathode version for interleaved CCM PFC. Moving across, this is a great example of our competitor friends versus the Genesic technology. This is a half bridge. We ran it at 150 kilohertz, which is a high speed for silicon carbide. And the result is that the competitor ran 25 degrees C hotter for the same conditions as the Genesic part. So we've got a thing called trench-assisted planar gate silicon carbide. It's the best planar reliability with the best trench performance together. On the right-hand side here, we have a great example for industrial applications where they have a maybe 1200 or 1500 volt rail. You still need to have power for monitoring, sensing, communications. So here's a great little flyback unit using our 1.7 kilovolt silicon carbide MOSFETs. And to wrap it up, this is our entry into the module era. So Navitas now has these SiC pack modules using silver sintered packaging technology on direct bonded copper. The first samples you see here, they're at 1200 volts, but we can go to 6500 volts. It's an incredibly wide range, the biggest in the industry, with really high reliability. So you can see here from 20 watts up to 20 megawatt applications for Navitas at PCIM 2023.
So thank you very much, Steven. I've seen a lot of products, a lot of new achievements in the electronics, very good for our engineers. And so I thank you very much for explaining to us, and looking forward to see you again very soon.
Grazie mille.
Thank you.